sponsors. Obviously, Chase is a huge sponsor. Downtown Denver Partnership, Comcast, give us all the great Wi-Fi. So if you run into any of these sponsors, just go up to them and say thanks, buy their stuff, make sure they stick around, they keep giving us more money. And we have a bunch of other sponsors. So these are all up on the website as well. But yeah, we can't really put on these events. You know, it's a free event, so in order to pull it off, we really have to have these sponsors. All right, so I'm probably going to be sitting up here a lot because there will be typing and not coding, but configuring involved. If you can't see anything or you want me to blow screens, just let me know. So I've been the CEO of Inversoft. I started the company about 8 years ago. I've been doing that for a while. We've got one product that is sort of focused on security. It's a user database and a user management system. So obviously, if you're going to be storing your user data in our database, you want to make sure it's secure, right? So based on that, I wrote an ebook earlier this year all about security. And then we actually put out a contest to see if people could hack our server, and they did. So we also have another piece about how they hacked it, and they actually went through, they didn't go through the server itself, they went through a sort of this backdoor process. So we had to lock down one thing, and they sort of tunneled their way through. The server itself is still very secure, and nobody breached the individual servers, but they found some really sneaky ways to get around it. I've had plenty of servers hacked. I've set up boxes, and then within like seconds, they start getting brute force attack from China. You know, I'm sure you guys have all seen that. So I've been doing this for 20 years or so, and I hopefully know a little bit about security, but obviously not everything. So I'm sure you guys can stop me as well. All right, so here's just some of the many statistics out there. There's a ton of these, and there was 30,000 hacks last year-ish. I forget how many hacks per day, but the number of breaches every day just keeps incrementing. And some of them are huge, right? Obviously, like LinkedIn, like a third of their database got hacked and just got sold on the dark web. Actually, Madison now is probably one of the bigger, funnier ones. And so there's a ton of them, right? So these things just keep popping up, and you keep seeing them over and over. I think one of the largest social networks in China just got hacked, and about two-thirds of their data got released on the dark web. So it's bad. All right, so that sort of brings us to this, right? The second you do anything online, you're going to start getting hacked. Like, at least people are going to try. So the server that we stood up to test, to write the ebook and then test it out, that thing started being hacked probably within about 5 minutes of coming online. And you can go look at the IP addresses; they're all China, a lot of Korea, so Russia. Right? You're just constantly getting bombarded by hackers. So you have to be on top of it, and you have to lock things down really fast. So when we provision servers now, they're like locked down right out of the gates. And I'll go to that. All right, so there's sort of two basic principles of security, right? There's the server security and the application security. And I kind of divide those into two logical buckets. And the first one that I feel like is the most important is your server, right? Obviously, if somebody gets on your server, they get root access. I mean, you're toast. It doesn't matter how secure your code is. So if you can prevent people from getting on your server, you're like 90% of the way there. Then you can obviously take a look at your application code and make sure that people can't get access to your data or get a root vulnerability or a shell or a remote terminal is another vulnerability. So essentially, what will happen is, depending on what you're running on your box, there's ways that people can port scan you, right? Everybody can port scan you. Just go install whatever your favorite tool is. I use Nmap. But yeah, you just install Nmap. You say Nmap IP address. It'll tell you everything that's running on that box, right? So if I flip over really quick, yeah. All right, now technical difficulties. All right, there we go. So yeah, I mean, so if I do Nmap, it just sits and it just scans every port, 0 to 65K. And it'll come back and say, here are the ports that are open. So obviously, Google is listening on the DNS lookup port, which is 53. They have HTTP open, which is an instant redirect to 4 port page. Right? So this is what people do. They hammer your box.
We've got some overscan going on. Can you shrink your window so you can see the edge of the text?
Yeah, I'm sorry. More technical difficulties. It looks all right over here. It's just that one that's messed
Maybe just bring your window in here. I guess I can't go for less. Yeah.
Let's just do this.
Yeah.
Is that better? No, we don't go.
Yeah, thank you.
All right, cool. Yeah, so this is like a simple tool. You can install it on any system. Instantly see what ports are open. Go list of known ports, and there's websites that will give you exploits for every port. And you just try them all until you get access. So, interestingly enough, the way that we were hacked was that we were running Elasticsearch. We were running an old version of Elasticsearch, unfortunately. It was running on its standard port of, actually it was running on a non-standard port, but it responds to Elasticsearch requests and it responds and it says, hey, I'm Elasticsearch, take advantage of me. And so Elasticsearch has this really bad vulnerability in the version that we're running. Oh, and it actually sends back the version string too. So if you query it, it'll send like, hey, I'm Elasticsearch, here's my version number, and it should just like print out a list of exploits, right? And so what they did is you can do a remote terminal. You can just essentially say, hey, Elasticsearch, why don't you just let me have access to everything on the box and just drop me to a bash shell. It's really awesome. So we locked that port down, right? But it was really easy for them to figure it out. They just knew all of our known IP addresses. They scanned them all, and they hammered everything and figured out how to tunnel through. So, be wary. All right, so going back, oh, I started from the beginning. How do I do that? Let me learn better keys. All right, so yeah, so I'll break these down into two groups, right? So the first one is server security. We'll talk about the architecture, how to lay things out, and like why you should do that, and why you shouldn't run everything on a single box. Talk about passwords, obviously, very good to keep your passwords secure. Remote access is obviously important. You have to lock that down. We added a little anal retention to our system, so we did two-factor authentication. You don't have to, but it's kind of fun. It's kind of annoying though to have to type in your code every time, but if you don't log into the box much, do it. Firewalls, intrusion detection, I'll go over all that stuff. So everything I'm going to talk about is Linux. I'm not a Windows dude, so I apologize if anybody's a Windows dude.
Are these slides going to be available later?
Yeah. If you guys just like give me your email address or a card, I'll take a stack of them and I'll just send it out to you afterwards. And I'm going to put a lot of this stuff on the SlideShare as well. So. All right, so server security and then application security. So there's sort of this run as user concept, right? So you want to make sure you lock things down that way. I'll get into that. We'll talk a little bit about SSL. SSL is sort of standard now. It's really easy to set up and install, so I won't go into too much detail. I'll just kind of quickly cover it. Password security, your app should do that as well, same way that Linux does it. And then SQL injection, configuration, all those things. All right. Everybody remember Leroy Jenkins? It's coming back. I'm bringing it back. All right, so this is a basic architecture. Can everyone see that? I apologize. Like, we couldn't figure out how to make this bigger and fill out the full screen. PowerPoint meeting plan, whatever. So yeah, I mean, this is a standard architecture layout, right? So you have your app server, and then you have a really, really strict firewall, and then you hit your database server, right? And this is pretty good setup because if somebody happens to breach your app server, they're going to have a much harder time getting your database server, and they cannot get to your database server from the outside, right? So that's where your user data is stored, and really that's kind of what we're talking about here. Like, because I could care less if somebody stole my code. It'd be kind of annoying, but you can kind of download it and decompile it right from our website. So stealing my code doesn't matter to me. It's stealing the user data, right? Privacy information, email addresses, password, all of that stuff. That's what everyone's sort of looking to secure these days. So that's why we say your database server should not be publicly accessible. And it should be only accessible from your app server. Now, a lot of people put a firewall in front of the app server as well, but really that's just to lock down access, right? Just lock down your ports and make sure people can't get to it. All right, so kind of covered all this, but yeah, application server is public, and that's sort of where people go through the web or get APIs if they're on mobile or whatever needs to happen for you to run your business. Database servers only has a private IP. It might have a public IP, but it's not listing on it. It just sort of ignores it because it's not going to use it at all. The only time it's going to use it is to get out and then have traffic come back in as it like goes to like maybe update packages or something. So your database server has to be able to call out, but nobody should be able to call in. All right, so what we did is we used on Linux. There's a cracked lib library, and it hooks into PAM. PAM is the pluggable authentication module or something along those lines. And essentially what that does is it says all user security, all user constraints, everything that happens to users when they log into your box, update their passwords, whatever, goes through that module. Right? And it's pluggable. So you can actually hook in at different key points and just say like, oh, I want this to occur. I want you to check this. You need to do these things. So a lot of the login security, password security that happens in Linux goes through PAM. So you can, there's a library called cracklib, and essentially what it does is it sounds like it's like a hacking utility, right? But it's actually to help make your passwords more secure. All right, so I'm going to kind of walk through that. Hopefully I can do this seamlessly. Tell me if you guys can see. So I got, and if this gets super geeky, I apologize, but kind of geeky. So I have a Bagger box open, right? Ready to rock. Vanilla Ubuntu 16. And I have this little script that I'm going to run. All right, so what I'm going to do is hopefully this works. I ran it this morning and everything was awesome, but I didn't do it in this room, so I hope it will work. All right, so go root. All right, so I'll install cracklib. Right? Boom, got cracklib going. All right, so now there's this file called etc pamd, which is just all the PAM configuration files and the common password. All right, so essentially what this is going to do is every time you change your password, this module, this configuration file gets called. So what I'm going to do is I'm going to grab this cool little configuration line. You guys don't really need to know how it works. I'll get into that in a second. All right, boom. So now what I've done is I've locked down passwords. They have to be super secure. So I'll go through that really quick now. All right, so what was that line that I jammed in that file, right? This is what it looks like. Can everyone see that? I'll kind of walk through it, right? So the first section of it is retry 3, right? So this part of it says password. That means like when your passwords get changed, you're doing password jump, call this code. The second part of it is whether or not it's required or not. You can ignore all this stuff. It's kind of too much info. But then this is the library that gets called. And then these are the configuration options. So the first one is retry 3. You got 3 tries to type in the same password twice to change your password. After 3, boom, you gotta log out, log back in to change your password. So it prevents people from hacking the password. The minimum length is 10. I'll get into this later, but yeah, set it to 10. You can even set it to 12 if you're really, really super hardcore. But yeah, set it 8 is short in password length. So set it larger. You have to have one uppercase character, so this it's a U credit, right? So when you set it to negative, you have to get it back to 0. So I set U credit to -1, which is essentially your uppercase character credit is negative, so you have to get it back to 0. My lowercase character credit is -2, so you have to have at least 2 lowercase characters. My digit credit is -1, so you have to have 1 digit. And then the last one is my other credit. So you have to have some sort of punctuation. You have to have one besides -1 as well. So these things are all configurable. There's a ton of options. You can just Google cracklib, and you'll see there's like this barrage of options that you can set. And you can be super hardcore about your passwords. So now if I go in and I try and change my password and it's too weak, it'll tell me. I'll be like, sorry, that password sucks. Cool. All right, so next sort of step is, all right, so now everybody who has an account can't hash any passwords. So now we gotta make sure that we lock root down. So root is the super user account. It has to be locked down. You do not want people ever getting root access unless they are a very well-known user. So these 2 commands are gonna sort of block our root account down. We're gonna make sure that root cannot log in via password. So I can't change the root account unless I have been specifically given sudo permissions or permissions by the system, right? So if you log into any normal Linux box and they don't have the root account locked down, you can just start trying to log in as root by substituting user to root, which is SU. And you can just keep trying. Just log in with their password, right? If password-based root login is enabled. So by setting their password to this star character, essentially what that means, it just tells the operating system, root cannot log in with password, period. You have to be a privileged user to become root.
Just one question about the recovery. There would be a situation in which the recovery system had might turn up.
Yes. So like all this stuff, once you start locking it down, yeah, so the question was, can you ever get hosed up, right? If you you have to recover a system. Like you get the system into a state where you can't access it, right? I mean, like, and I've done that so many times. Like it's brutal. But yes, like the stuff. Once you start locking things down like this, recovery becomes really challenging. That's why you have to get good at doing it step by step, and then knowing how to set up user accounts correctly so that you can go in and recover it as a normal, ordinary user. And so I'll get to that. But yeah, once you give somebody sudo, and as long as you know your password, then you're good. You can always get to root, and you can always fix things. There's also console access, which is pretty valuable. Some internet, like cloud providers, have console access, some don't. We use Linode for some of our stuff. They have console access. Essentially what that means is it puts the machine into single user mode, and you just sort of get logged in as root, and you can do whatever you want to it. So it's kind of dangerous. Most boxes have console access by actually going up to the physical piece of hardware, Control-Alt-Delete essentially, and then you hold a button, and then once you get into your grub loader, which is the thing that starts the operating system, you hit U, like S or U or something. And what that'll do is it'll put it into single user mode, and it'll just drop you right to the console. And that's pretty secure because you're standing in front of a box, right? Like unless somebody hacks your data center and gets into BIOS, which is super unlikely, they won't have access. So that's another way. You can always recover boxes, but sometimes it becomes really challenging if you screw it up bad. All right, so let's go ahead and do this. All right, so I'll go back to my script here, and I have all these commands just sort of like set up. All right, so there's this. So now root cannot log in without a password. Right, again, these things are super, like, I have a script that just runs all these things. It only takes about 20 seconds to log a box once you know all the steps. All right, so then what I'm going to do is I'm going to edit the sudoers list. So the sudoers list is a thing that says, like, hey, this user can become super user, right? Super user do. And interestingly enough, the dudes that wrote this used to live in Boulder and used to work for a company called XOR. And so they maintained sudo, like that was like sort of their full-time job, that's what they did. So it was an IT company, hosting company, where they hired the guys that wrote sudo. All right, so sudo's changed over the years. There's this new thing, and this took me a little while to figure out. So there's these new defaults. Well, I mean, this has been around for a while, but it defaults now in Ubuntu. So they set these exempt groups. Once you're in an exempt group, you can do whatever you want, essentially. You're exempt from like having to type in your password and a lot of other things. So you have to remember to remove these. These are super insecure. So that's like one of the first things I do now is I delete this exempt group sudo. We don't want any specific group to sort of be exempt from our security policies. Okay. The other thing is, if you notice on some of these lines, or really just this one right here, it says no password. What that means is anyone that is in the group sudo can become root without having to type their password. That's really bad, in my opinion. If I leave my terminal open and I accidentally go, grab coffee or something, anyone can log in. So you need to remove this. This has to go. So you just delete that, and boom, now you're good to go. Or you can just add users to the group admin, because the group admin, you can see here that %admin, they have the same privileges that now @sudo does. I'm sorry, %sudo. So I do it. Save that file. Oops. All right, good. So now we've essentially locked the root user account down. It's really going to be challenging to become root unless you've been granted that permission by some sysadmin. Right, before I blow this thing out of the water, I need to go create myself a user account so I can get access to this box, like you were saying, because if I host something up, I at least need to have access, and I need to be able to become root to fix it. So what I'm doing is I'm going to create my own user. I'm going to give them a group of sudo, and then I'm going to give them a default shell, whatever, create their own gear, all that stuff, right? But I want to make sure that I have that group to start. So if I don't give myself that group and something gets hosed up, that's it, I'm toast. I have to console into this thing and fix it. So now I've got a user account, and now I can password that user, and I can say, oh, it's too simple, right? So boom, there's Cracklib telling me I did something stupid, trying to set password to password. But I can't. So I'll pick my horribly complex 16-digit password. Oops. Boom. Okay, so now my user is set up. I have sudo, so I can become root and fix the box or do whatever I need to, but I have to type my password to do that. So super important. All right, cool. All right, so next couple of things is we want to lock down the box so it requires keys. So I'm assuming everyone in this room has some variant of Linux running for their app, for their website, company, whatever, right? Everybody using key-based authentication currently? Anybody who's using AWS inherently does. Those that aren't using AWS, you have to kind of set it up yourself. So I'll step through that, even though AWS gets you over a lot of these hurdles, but I'll walk through it. All right, so we want to make sure we use keys, right? So what does that mean? That means I create a public-private key pair using some sort of encryption algorithm, whatever it might be, RSA, DSA, IPI, whatever, it doesn't matter. I create a private key and I keep that on this machine, right? So this box, and I don't give it to anyone. I make sure that no one else has access to it, and I make sure it's double encrypted or locked with a passphrase. And the passphrase should be really long, right? And that just makes sure that even if somebody steals my laptop, they still can't access that key because they have to know my passphrase. If I had a password phraseless key, if somebody gets my box, they get in, they can do whatever they want on any of the servers that I have access to. All right, so once I have the private key on this machine, I can take that public key and I can put it anywhere in the world, right? I can give it to anybody, I can put it as my email signature, it doesn't matter, because it's public. The server and my machine, when I'm logging into it, do a little handshake, right? So they say like, hey, I'm gonna encrypt something and you're gonna prove who you are, and you have the private key and I got the public key. So there's this little handshake that goes on, and that's how that security works. Don't need a password to log into the box, I just need those keys, and I need them set up in an appropriate manner. So it looks a little bit like this. This is probably really small. Again, I apologize. There's not having this in full screen. But, all right, so the first thing we'll do is we'll create a key. SSH Keygen will be your friend. You'll probably create a ton of keys in your lifetime. And then I've already created a user, so I've already set that up. But then what we're going to do is we're going to get that public key over onto my server, so that way I can log in using this public key, private key setup. All right, oh, and one last thing, and I can talk about this in more detail later, but SSH agent is going to save you so much typing and so much annoyance. And it also secures your whole life. So what the agent does is when I log into a remote box, the first handshake occurs, right? So going from my laptop to server 1, there's that public key, private key handoff. If I'm going from server 1 then to server 2, I either have to have my private key on server 1, which the more times you copy your private key to other servers becomes more or less and less secure, or I can use what's called an agent. So what I can do is I can actually create a little tunnel back through all the machines I've logged into, and every time I log into a new machine, that machine actually tunnels back through and connects to the private key on my laptop. So it just reduces your headache a lot. So I've aliased SSH on all my machines to SSH-A, which enables that agent for you. So you can tunnel back through and into your keys. Save yourself a lot of headache by doing that. All right. Fire this up really quick. Go back to my little scripts. All right. So I'll log out of my Vagrant instance, and I'll go ahead and create my key. Actually, I got to remove it. I forgot to do that right there. All right. So I'm going to create my key. You can use 2K bit length. Some people say that's now too short, and you should favor 4K. Sorry. So this B right here tells you how many bits are going to be generated in my keys. 4096, I've heard, is what a lot of people are pushing for. It's a lot more secure. These things are monstrous. So like hacking one of these will take like supercomputer-sized power, right? So 2K is probably still okay, but if you want to be super anal, you can do 2K or 4K. Too many arguments. That should not have happened. This happens sometimes because the program I've been editing my little script in. Here, I'll just type it out. Sometimes I get weird characters in there, and I don't know why. Okay, here we go. So it asks you for a passphrase. I highly suggest you always type one in. So I have my cool little passphrase. And I actually make it a phrase. I can't say it literally. Some people just have some like crazy string of characters. Like I actually type it in. So like, did you guys read that? I think it was XKCD, the horse battery staple thing. So I should have put it up. There's this classic cartoon about entropy, right? And so we always create these really complicated, hard to remember passwords that are just uppercase, lowercase, digits, randomized. That's good, but if you just pick 4 words and separate them by spaces and they're totally arbitrary, you get roughly the same amount of entropy, right? So you get roughly the same amount of security as long as they're long. So that's a really good way to pick passphrases. So like passphrases might be the first line of your favorite poem, or like, you know, your favorite book, reverse order with the author's initials. You know, just think of something that's easy to type, that use spaces, separate things out, make it long. That's really good.
If I may, want to beat me at 4 for the T.
What's that?
Beat me at 4 or beat me Friday for the T.
Yeah, exactly.
With numbers, with the @ sign.
Yep, exactly. Yeah, so like I have one that has a couple of words, a number, an exclamation point, you know, @ sign. So you just like mix it up. Sorry, I might get booted. Okay, so when passphrases are long, this happens a lot. You type them over and over. But luckily, you only have to type them like once a day or so. So it's not that bad. All right, so I'll just use password. Yay! All right. So yeah, the longer they get, the harder. All right, so I got my keys. And so if I look at my SSH directory, right, now I have these 2 keys right here that are kicking it for my demo. All right, so now what I'm going to do is I'm going to push those keys into my vagrant instance, and I'm running locally. So I gave it my hard-coded IP address, but essentially what I'm going to do is, I'll kind of type this out, I'm going to push that key by SCPing it from my local box to my vagrant instance in my home group. I tend to put things in either temp or home group, but if I put them in temp, I make sure I delete them like the second I have them, or move them out of temp. All right, so perfectly long password. Cool. So now my public key is over there. I can now SSH into that box. Excellent. And now I'm going to move it into place. So there's a file, and it's called, or there's a directory called SSH. So I create that directory. That's where all the cool SSH stuff goes. And then I move my public key to this file called authorized keys. And it's actually just a list. I know it doesn't exist yet, so I'm just moving it in there, but normally you would append it to the end. And it's just a list of all the keys that are allowed to access this user on this box. Right? So all the public keys. So I do so, and then the last thing you have to do is you have to remember to make it not world readable, right? Obviously people sometimes will have it where if you create a file or create a directory in your home dir, it's instantaneously world readable, or at least readable by your group. You can't do that. So all your SSH stuff has to be locked down. So what I tend to do is I tend to chmod, change the permissions on it for SSH, make it so only I can have access to that directory itself. And then what I do is I go ahead and change the ownership of all the files underneath my SSH directory, so only I can read or write them. And this is required, otherwise the keys will not work. They have to be locked down. All right, so we're good. I think we're good. So now I can go ahead and try it. See if I can log into this machine. Ooh, and I get a nice little pop-up, right? So this is cool with integration with iTerm and Mac, is that it'll actually save my passphrase, and I can tell it, to remember it or not. So I type in my super secret passphrase and password. It unlocks my private key so that I can use it, and it does a little handshake negotiation, and boom, I'm logged into the box. So now my private key is unlocked, and it stays unlocked technically until, you can set timeouts on these things, but it stays unlocked until I log out and log back in. So that's something to keep in mind. Once it's unlocked, it's the same as sort of being passwordless, unless you instruct it specifically to lock it up. So if I log out and then I log back in, I don't have to type a password. It did the key negotiation, boom, I'm in the box. So it makes life easier as well, and it's way more secure for passwords. All right.
Next question there.
Yeah, what's up?
Save your passphrase in your keychain.
Yeah.
Isn't that the same as not having a correct passphrase?
Yeah, exactly. That's why I never check it. Yeah, essentially what you're doing is you're unlocking for all time on all your devices. I mean, the keychain, all right, so here's the cool thing about, what I like about Apple products, right? So like, everything's sort of encrypted via your keychain. It's stored in the cloud, sure, but it's encrypted before it's pushed up. And like iCloud is really secure, you know, compared to if you look at like Dropbox and Google Drive and some of the other solutions out there, they do a lot of local encryption before they push files up. So like, they've actually done a really decent job of securing things. I mean, their whole system's built on Unix, right? So it's inherently they already have all of the roles, permissions, and levels of security, and so they just kept building on it. So like I have Touch ID enabled on my phone with a large password as well, right? Because that's really the only way you can do Touch ID. Touch ID hooked up to my keychain, and then I have a long password over here. So yeah, I might push those things up into my keychain, but I feel fairly comfortable because it's biometric and it's two-factor. So I tend to like the way that they've done it. But yeah, you're right, it's pretty insecure overall. All right. So now we've got a fairly good setup. However, China can still hack you, right? They can brute force attack you. It's harder to get in via root at this point, but they can try and hack my account brute force to get back in. So we're going to try this. The thing about two-factor authentication is you have to have time. Everything's based on time, right? So this is a ISO spec from I don't know how many years ago. It's been around for a really long time. And essentially what it does is it allows you to generate these codes on two different boxes as long as they're time synced. So that's what we're going to do. We're going to make sure everybody's time synced. We're going to install all the modules. We're going to set up two-factor. I'm going to do it on my phone. I have a little app. There's a ton of them. And you just take a picture of a QR code or whatever it is, and boom, now you have two-factor. And you can do all of this on that. It's pretty cool. All right, so let's fire this up. All right, so here we are again. I'll become root. Let's go out to type in my password, which is good. All right. I'll just kind of keep shrinking here. All right, so this is another PAM module which hooks into that authentication system. So this is the Google Authenticator PAM module. There's other ones out there, but this is the only one I could really get to work consistently across distros. I like it. So yeah, I'll install the Google PAM. All right, so that's the first step. Now I have to enable it, right? So what I'm going to do is there's a PAM file called SSHD, and what this PAM file does is it essentially says, instead of like where you're changing your password, call these modules. Now when you're logging in through SSHD, call these modules, right? All right, so at the top of the file, I'm going to jam in this line of configuration right here. You guys see that? All right, so essentially what it does is it says, for authentication via SSHD, go ahead and call this PAM Google Authenticator module, and then there's a couple of configuration parameters in here. But essentially what these mean is that if you get a success, that means you're logged in, or this module is finished. So don't execute the rest of the stuff in this module. The default is to die, which essentially means if you fail, just fail. You now are not authenticated, right? Okay. So we're good there. And now what I'm going to do, and this is where it gets a little dicey, but I don't think these things in correct order. You can kind of break your box. All right, so there's two parameters that we have to configure in SSHD, and they are for how what modules get called when you log in to challenge you to authenticate yourself. So normally it's just a password like, hey, please just type in your password. When it's key-based, it says, hey, present me with a valid key so that way I know who you are. So we're going to change these and we're going to add some to the end. And these two are, we're going to have a challenge response yes, which essentially means that like after you've been authenticated via keys, still pop something up that asks for more stuff, either a password or a key or a code. And then the other one is this. So this says, okay, the new authentication methods that we're going to allow are public key, which is that RSA key handoff that we just did, as well as keyboard interactive. Normally, when you have password-based login disabled, keyboard interactive just is like doesn't make any sense. Because keyboard interactive is where you like actually type in your password. So we're not going to do that before, but now we have to add it back in. We have to be able to interact with it to type in our one-time password, our codes. So we have to add those two in. The cool thing is, if you don't have your own one-time code set up, what you'll be prompted for is your password, which is still okay. You still have to have a public key, so you still get that RSA, the public key, private key authentication enabled, but then you also get access to your password. So it's even like just yet another level of security, right? Not like anyone's going to hack your keys, but if they happen to, they still have to have your password. Or your one-time password for two-factor. All right, we're good there. So now, I'm going to restart SSH. And I'm going to enable Google Authenticator, right? And I believe, let me just double check. Oh, and I was missing something. We have to time sync everything. So this is super important. This is happening, like lock me out of your boxes. If you don't get everybody synced to the atomic clock, and you have even just like a couple of seconds of like delay on your side, things can get really messy. So your keys can start down. If you have a minute delay, you're screwed. You'll never be able to log in. So make sure that everything is time synced to the atomic clock. So Macs, by default are synced to atomic clock. A lot of Linux boxes, when they come out of the box, aren't. You actually have to install that. I don't know why they don't do it by default, but just go install NTP. Essentially, that's the network time protocol, and make sure your box's date and time is always synced to the atomic clock. So it's good for everything, not just security. All right. Yep. Grab this. Oops. Sorry. I'll lock in. All right. So what I'm going to do is I'm going to create a key for my user that sets up two-factor authentication. So there's this Google Authenticator tool, and it's kind of cool. What it does is it says yes, and there it is, right? I might have to make that a little smaller so I can get it on my phone. But there's my gnarly QR code. I don't know how it draws it. Probably some sort of like ANSI library or something. I can't see where the edge of the screen is. Hang on. There it is. Alright. So I have to make this smaller enough so I can take a picture of this with my phone. There it is. All right, so here's the QR code that enables my phone to sync and give me those codes. And then if you notice down at the bottom, you probably can't read that, but there's these scratch codes. Write a couple of those down, because if things do get busted, you can use those to just log in. But they only work one time. So if you bust through one of your codes, you need to go generate more scratch codes. But what you can also do is there's desktop applications for this, but you're just going to grab that secret. There's like a secret key that always gets dumped out. That's really all you need. So you just take that and you can essentially plug it into any of the one-time password two-factor authentication apps, and it'll generate correct codes. All right, so where's my phone? All right, so I have one on here. It's called OTP off, which is just one-time password off. I can scan barcode. Comes up my camera. I'm good. Okay, so now, moment of truth. Let's see if it works. Monitor. Sorry, I'm trying to fix this over. It's everyone on the screen. Okay. Yes, I'll answer these questions. You can read through these. These are essentially just being more secure. Like, hey, do you want to rate limit this so you don't get a lot of login attempts at once? Do you want to time things out? If there is time delay between the two servers because NTP failed or whatever, what's the gap that you want to specify? You can say like, well, give me a minute and a half, buffer. So that way if my two machines are not time synced perfectly, I'll have a little window, a little leeway. All right, so let's go back into this bad boy. All right, so now if I log in, there we go. It asks me for my verification code. Bigger. I think I'm going to run it like serious. And then put it. Okay. That should be good. All right, so here we go. 1, 2, 3. Sometimes it doesn't, and you're like, oh, crap. And then luckily you can just scroll back up and use your scratch codes. They're right there. But yeah, if you accidentally clear your screen or close this window, you're sure closed. You don't get it the first time. So really important to write down those scratch codes. All right, but it works, right? So now I have two-factor authentication. Like, this is super anal retentive, but you know, why not? If you have hundreds of thousands of pieces of user data on your server, you do not want to get it hacked. And you probably aren't going to access that server every day, so do this, right? There's no reason not to. You log into it once a month. Fine. Type in one code. It's really easy. All right. Jump back over here. All right, so next headache from being hacked during our contest, you want to make sure that you lock everything down that doesn't need to be world accessible. So you can have a port open on your server that's being used internally through localhost and loopback, and that's fine. IP tables won't interfere with that, at least not the way that I set it up. But you want to make sure that you can't access it from the outside. So if we had simply locked down our server so it would only listen on port 80 and 443, which is essentially our website, we wouldn't have been hacked, right? They wouldn't have been able to exploit Elasticsearch. But instead, we have Elasticsearch port happily listening to the outside world, and that's how they got through. So on Linux, it's pretty easy to do this stuff. IP tables is kind of a beast, and there's not a ton of good docs out there, actually. But I wrote an ebook on this stuff, and I actually will walk through kind of step by step each of the pieces of IP tables. And I think at some point I'm going to blow that out, right? Because it's so underdocumented, it's really so hard to figure out and navigate the IP table language and like their configuration files. That if I can blow it out more, I think it will help a lot of people. Because it took me like days and days to figure out how to do IP tables effectively. All right, so what we're going to do is we're going to install IP tables persistent, and that's a package that essentially, if you make any changes to your IP tables, they get persisted, and every reboot they get installed. So you can do that manually if you want. It's kind of a pain in the butt, but if you change IP tables, essentially if you change the rules for networking on your server, the second it's reboots, you lose them. So this package does all of the persistence for you. So on boot, it sets it up, and then if you make changes, it saves it to a file. Right, so it's just kind of nice. This up real fast. I think it's the next plane, right? And root again. Everybody see that? Okay, all right. And then come over here, skip all that, John. All right, here we go. Yes. Okay, so essentially what this is telling me is like, hey, we noticed that you're installing this for the first time and you may have set up a ton of rules. Do you want to save those rules that you currently have set up to our file? So this is nice. Like if you spent the last 3 hours setting up these crazy IP table rules, this will save it for you automatically. I don't. I have no rules. So we're going to create them from scratch. So there are these IP table files, one for IPv4 and IPv6, right? So you really only need to deal with IPv4, but you can set both of them up if you want. And they're pretty much identical. They just have the extra padding of zeros in front. Yeah.
We're not really trying to do any complicated stuff.
Absolutely, that's fine too. Like, I tend to favor a little bit more getting into the configuration files, but yeah, I forget what there's like simple firewall is another one. UFW is another one. There's a bunch of them. Those are actually pretty cool because they'll just like take you through a wizard and they'll be like, do you want to have more video? And you're like, yeah.
I can actually remember the commands for those and come back on them later.
Absolutely. And what they're doing is they're simply just creating the rules files that are so hard to figure out. Right? That's all they're doing. They're essentially setting up IP tables because that's what the kernel uses. Essentially, it's the kernel mod, but essentially that's how it works, right?
They're secure.
They're totally secure. It does the exact same thing I'm doing. I'm just blowing out the files manually, essentially. But yeah, no, I've used those on a number of boxes. They're really good tools. All right, so the way that this is set up is that there are these chains, right? There are these like what happens when I get a request inbound? What happens when I get sending a request outbound? And you can chain all these things together so that there are these handles, so like input, forward, and output. So input is like somebody's sending me bytes. Output is I'm sending bytes out. And then forwarding is they came to me, but I'm handing them off to someone else, right? So you can, and again, that's why this stuff is so complicated and like a lot of those tools help, but figuring all of this out can be a total nightmare. took me a really long time to figure out what these things in brackets were, so I'll just kind of give you guys a heads up. They do absolutely nothing. All of them. And, like I Googled for hours to figure it out. And I was like, IP tables bracket, nothing. IP tables bracket after chain, nothing. You know what I mean? Like, what do you type to figure that out? This is the number of bytes that have been sent and received on that channel. It's it. It's just a plain old dumb number. You could put 42 in there and it wouldn't make any difference. It's just a counter. So IP tables just increments that counter every time bytes come. I have no idea why they do that. Fine. So yeah, save yourself the headache and just ignore the numbers. All right, so here's my crazy table, and I'll go through it just a little bit because again, these are crazy complicated. But essentially, what happens is when IP table starts, it loads these rules and it just runs them. So this is like actually a command that gets sent to IP tables, -a, TCP, -b, right? So I can type in IP tables, copy paste that, and it would work the same. They're just happen to be bucketed into like these groups. So like this is the filter. The filter essentially says like, okay, when I get packets in, what should I do with them? Like, you know, I need to filter them out, right? So I'm going to send it to that filter chain, that segment of IP tables. And there's other ones way down here. So there's raw, NAT, mangle, and security. Most of those you'll never, ever, ever need to touch. But you might. So like mangle is if you actually want to interpret the bytes and change them. So you can like rewrite headers and TCP and stuff. So it's pretty cool. And like that's how a lot of like load balancers work. And so they can kind of mess with packets and like reroute things, right? You can do a lot of that through IP tables. You can actually use forward and mangle and pull that off. I don't suggest you do that. It's really complicated, but if you want to help for it, might start out. All right, so mine's really simple. Essentially what I do is I create these 3 custom protocol chains, essentially one for each of the protocols I'm interested in. So UDP, TCP, and ICMP. Okay? I shut everything down by default, which essentially means I don't care what you're sending me, you don't get it. And then I add things in as I go. And so that's what each of these rules are. So when port 22 comes in on the TCP protocol, accept it. Let that packet go through. And that's 22 is SSH. Same thing for 443, same thing for 80, et cetera, et cetera. These are just examples of other ports you might want to add, 3000 or whatever, it doesn't matter. You have other things like API calls. You can set up ports for whatever you need. These are all just sort of like letting me talk to myself. So like if the input is the loopback address, please just go ahead and accept that because that's me calling myself. I don't really need to worry about anything hacking that loopback. It's sort of impossible. And then these help me figure out if somebody is already connected to me, I don't want to terminate their connection, right? So there's all these connection track, like new and established, related, all these things. And so again, it's complicated, and the simple firewall and like a lot of the other utilities do a lot of this work for you to figure it out. But you can go read my book. I kind of go through some of these things in detail and walk through like why you might want to do that. Okay, so if I run this IP table rule set, it'll lock down my box, and it essentially won't listen on anything except for these 5 ports I set up. Hopefully this works. I didn't blow that file out of the water. So what I do is I need to restart or reload my configuration. So there's this net filter persistent reload. So that it's, I don't know, Linux drives me absolutely crazy sometimes, but the package is called IP tables persistent. The service is called net filter persistent. Go figure, I don't know. Anyway, I reload it. Good. If I flip over to my other tab and I nmap my vagrant box, I should only see those ports, right? Or actually I should see nothing. I think it's only listening on 22. So they're closed, but they're open to traffic if I had something listening on them. Right now they're closed. There's nothing actually listening on them, but it at least accepts them. And the way that it knows how to do that is it doesn't immediately say no. The server doesn't. The server just ignores it. And so nmap says, well, it looks like you're ignoring me. Therefore, I'm going to assume that you're listening on that port, except there's just nothing running on it right now. And so that's another thing. If you scan some boxes, you'll see a ton of ports that just say closed. That's fine. I'll just keep hitting all those ports until something comes open and starts listening on it. And just come in. that, and always redirect 80 to 443. Oh, and 22. Okay. Never want to close down 22 because then you sure can't get to your box. How are we doing for time? Good. My watch is telling me to sit up or to stand up. Got to close my lips and gamify my life, right? That's good. All right, so this is kind of one of the last cool things that we've done, and there's a ton of tools out there. We just happen to pick Monit because Monit is simple. It's been around forever. It's easy to configure, whatever. But there's a ton of other things. There's one called OSEC, which is much more comprehensive than Monit. And so all of this stuff, all that this stuff does, is it watches your server and it sees what things happen and then it sends you an alert. Super simple. So what you can do is you can actually watch for certain file changes and certain things that happen on the server, and then it'll just send you an alert. Like if someone happens to log in, an alert. OSEC does this, but it does a billion times more. So it'll actually can tell when people log in, and if they do something that looks fishy on the box, it can alert you to that. It's like this is like a new behavior, right? So that like OSEC is Monit, but like on steroids. It's super comprehensive in terms of intrusion detection and overall server security. The other thing that Monit can do, which we don't use it for, but it can watch services, and if they crash, it'll just restart them for you. Right? So if it sees that SSH Keys for whatever reason crashed, it'll just restart it. So Monit's a pretty cool tool. Again, it's been around for a while. And you can, by default, it just sends emails, which is fine. But we took a little extra step, and we have it send Slack notifications to our Slack server. So that way, anytime that anyone logs into a box from an unknown IP address, that's another thing. It doesn't get really chatty, right? You can get like alerts nonstop. If you have good known IP addresses like your house, your office, you can whitelist those, and then it just won't, it'll ignore them. And then you get a weird login request from some weird IP address, and then you just send something out to Slack and say like, we just logged in your coffee shop, and where are you? So as long as it's not noisy, it's a really good tool for the whole team to manage like what's happening on the server when you're not on it, you're not actively watching it. Stupid words. All right, so I'm gonna set this up really quick, and then I think what I'll end up doing is kind of walk through the application stuff. There's less code and like demo stuff there, it's more just like information, and then we can use a Q&A if there's other questions. Sound good? So I'll try to go fast. I know this is long. All right, but the Monit stuff is cool. So I'm just going to copy and paste and try and go through it quick, but it's pretty slow. All right, I'm already grouped here. So I'm going to grab my Monit. And it's got a cool name too. All right, so what I'm going to do is I'm going to create a configuration file for Monit that essentially says, hey, watch the auth log file, which is var log auth.log, I think. And that's where, like, whenever anybody becomes root, like, does sudo, logs into the box, does anything, it gets written out to auth. So it's a really nice file to watch, and you can see as it changes, you'll get notified about what's going on. All right, so I grab this little configuration, and I'll walk through this really fast. All right, so check the file, var log, auth log, right? Oh, and if it happens to match this little string, this keyboard interactive /pam, then go ahead and execute the script I wrote. So what will happen is in the auth log, this is what gets written into it when somebody logs into our box now. And the reason that gets written into it is because we enable two-factor. If you don't enable two-factor, it'll say something else. It'll actually say accepted public key. If you don't have two-factor enabled. If you have password enabled, it'll say accepted keyboard interactive /password or something. So you have to make sure that it matches exactly how your box is set up. And once it does, and there's a line written to that file, Monit will kick off and do whatever you tell it to do. So in this case, I told it to execute my little Ruby script. All right, so let's create that script. First of all, let me change the delay on this. And I'm only doing this because normally it's set up to check at 2-minute intervals, and for a demo, that's really lame. So set it for 2 for 1 second. You can leave it at 2 for production. You can set it to 1 if you want. Set it to a second. Doesn't matter. It's not going to take up that much load to check the file for a second.
What's it checking again?
It's checking the auth log file, right? So essentially what it does is when Monit wakes up, it runs through all the rules it has, and And if the rule says, hey, go check this file and see if it's changed since the last time, do a diff on, essentially look at the lines that have been written that are now different than the ones before, and check to see if any of them match this text I'm telling you to look for. You can do regex, you can do a ton of stuff.
So you can just look for like failed attempts, like block.
You could, and that's another thing. So like OSEC will watch that file, and then it can actually watch a little bit lower, and it can say like, oh my god, this IP address keeps hitting me. I'm just going to blacklist it for a few days, whatever, and then it'll bring it back out. Right? You can do that in Monad. It's just a lot more scripting. OSEC, it's a lot more configurable. So like you just say like, watch IP 20 failed attempts, blacklist 2 days. It's a lot.
That kind of the most common.
What's that?
That's kind of like the most common scenarios like that I see is that you just start getting pegged and it actually affects performance.
It can.
And then it stops.
And then it stops. Yeah, and it's good to lock it down if you are having performance problems. We don't tend to see a ton of that. It's just like, China's just keep doing it, continually hitting us, and it's such a low load because they just open it up and immediately ask for a key and they shut it down. Because once you go to key-based, your login attempts get lower and lower. The bots know to stop.
So I feel like this is better than something like failed to ban.
Sorry, what's that?
Is this better than the failed to ban?
They're about the same. All the tools are going to accomplish sort of the same goals. It just depends on how down in the weeds you like to get and how much configuration you like to manage, or if you would much rather just go through a wizard. So there's a ton of tools out there. All right. I would have set up Monad to email me, but that's not fun right now. But yeah, you can set it up so that it'll email every time there's an alert. Instead, I'm just going to create this file. So I'm just going to create this file. I'm just going to grab this next. So essentially what this does is, this is our cool little Monad script. It takes our webhook, and that's just to notify our Slack channel. This is a specific Slack channel for us, which is we have login alerts as a Slack channel. And it'll just send a little notification request through Slack. This will also work with pushover. So I wrote the script so that pushover as well. Pushover is cool. It's just like a cool little app that you can download to your phone. I think it's like $3 or something. Once you buy it, you get sort of unlimited notifications from it. So pushover just has a simple API and you can push anything, and it just does push notifications to your phone. So it's a really cool way to set up push notifications without buying a bunch of software. You're not going to buy 12 or whatever, 12 here. All right, cool. So I think this is set up. Make that thing executable. Restart the Monad. Okay, good. And that's nice. All right, so now we should, hopefully this works. I'll log back into this box. It'll see the change in the file, and it'll go ahead and notify me on my Slack channel. So let's try it. Oh, shoot. I don't have verification code. Second. Oh, and the OTP auth app does Touch ID as well. So it encrypts everything local on your phone using the Touch ID. So it's even better. So now I got two-factor on my two-factor. All right, come on, Slack. Come on, Slack.
I got it.
Did you? Yeah. Nice.
Screwing up my video.
There it is. It didn't pop up, but server login to my Baker VM, content matched. Can you guys see that? I don't know if I can make this bigger. Oh, there it is. Nice. Go. So there it is. Content matched. Keyboard interactive PAM for Pontarelli at this from this IP address on this port via SSH tier, right? So you get quite a bit of information. You could beef that up if you wanted to, but we figure that's a decent amount of information for us to know exactly who's logging in under what account from what IP address. And so yeah, I can just take this IP address. It'd be really cool if I made that a link and it was like clickable and it doesn't matter where in the world go overkill. So anyway, that's a basic rundown of like how to secure your server. Some of this stuff is overkill, of course, but if you're not going to be logging in the box a ton, why not?
That's a script you're doing. Just run that script and does all that for you.
Yeah.
Is that part of your slides? Are you going to get that away? Can we have
I will figure out a way to get that script in there. It's not in the slides, but you know where you can get it? We have a GitHub repo. I was going to generate a hash using one of those Bitcoin rigs for every possible password, up to 9 characters. It would take me 1,000 seconds, right? Also known as 16 minutes. So I can crack one person's password in 16 minutes, roughly. If I limit it to 8 characters, it takes less than a minute. So I just rip through these things. And these Bitcoin rigs are not expensive. Like 1 terahash right now is about $200. So for 2,000 or 20,000 bucks or whatever, you can blow things through the roof, right? And if you have access to a lot more, I mean, it just gets easy. So these things keep getting faster and faster each year. When I originally started doing some of the research into this, like a teraflop was still pretty expensive. It was like 15 grand. And one of the Bitcoin companies just came out with a rig that it says it does 7 terahashes, and it's 250 So the technology is coming around so fast, and the prices are going so low that we are going to be screwed if people are trying to brute force attack passwords. Think of like a consortium of like a bunch of machines too. We add that to the mix, or a bunch of rigs, and then just start giving you spare cycles, and you can root through this stuff. All right, so the pain here is that. Wait, go ahead.
I'm sorry, can I just make sure I understand what you're saying? You have uppercase, lowercase, special character, numbers. Right now, 16 minutes? Or
16 minutes for a 9 digits.
9 digits.
9 digits. Once you add another, you go to 10 digits, it gets much longer. It's like 3 or 4 hours. And then when you go to 11 digits, it gets to like weeks or days or months, right? So like
And it should be years.
it should be like millennium, right? So it should be like massive,
That's changed very quickly.
really fast. Like it used to be that a Bitcoin rig they were right around like gigaflops. Like they were like doing some decent sized gigaflops. And within like the last 9 months, they're doing tera. And that's funny, interesting, and kind of humorous, because the Bitcoin value is going down, and these rigs are going up, and so people are generating like really crappy coins faster. I find the Bitcoin stuff amusing. But the reason that it's interesting is because they're doing the same hashes that we're doing on passwords. That's what they are. They're these huge hashes. That's what Bitcoin is.
So maybe you're getting to this, but how many characters that you need right now? I don't have to worry about it in my life.
Okay, so it's, yeah, if you have a password that's 16 characters, you're probably going to be good for a decade or so. But the kicker there is really, it's less about the password length. I mean, longer password's better for you. It's more about the algorithm. So what we're trying to do is we're trying to slow things down, which is funny because in computer science, we're trying to speed things up all the time. When it comes to security, we want things to be really slow. It's because we want to make these big, huge, massive computers do things just as slow as we have. So we're trying to pick an algorithm that's super slow, complicated, and cumbersome. Right? So more iterations is good, more load on the box, you're taking up all your GPU, you're pinning your CPU, these are good things, unfortunately, right? All right, so this is the problem. And you got, anyone play Pokemon Go? No? Just a few? Wow, all right. Did you guys use Google or Trainer Club to log in? Google. All right, the reason that most people use Google is because Google could log you in. Trainer Club couldn't. And the reason that Trainer Club couldn't is because they were having problems with hashes as well as other things, but they're like using bcrypt at a really high load factor. It's so slow that it takes so many machines. They would spin up like hundreds of machines a day to go through peak load times just to do hashing. Right? So this is what sucks. It's so annoying that you can't build a really robust login system. You actually have to build a really shitty login system because it's more secure. So this is what it kind of like, this is sort of what it would look like. This is a really cheesy graph I built yesterday, like in about 4 minutes, 2 minutes. It took me a while to figure out how to do it. So like every time that you have more logins, you have to add a box because your hashes are so slow. If you're gonna have 1,000 logins per second, and it takes like a second to do a hash, you have more boxes. Like you won't be able to handle that volume, right? The box will be pinned. So it's all based on how many logins you have, and it equates almost directly to how many hashes you can do on the box you have, and how many boxes you need. Because you want it to be slow. That way we let the brute forcers, you say you guys are screwed.
You're saying you want it slow just so that the brute forcers, the iteration makes sense?
It's ridiculous, yeah. So the current standard is you should be using either SHA-256, which most people, or SHA-512, most people say don't use it, it's really insecure. But if you're going to use it, use a really, really high iteration count. So essentially that means you take the password, then you SHA it, and then you SHA it, and you SHA it, and you SHA it. You keep doing that, so do it about 200,000 times. Because you need a lot of zeros, and it needs to be really slow. That's it. If you're using bcrypt, the current load factor, I think that they're saying is 12. I think bcrypt goes up to 16. 16, the difference between 12 and 16 is like asymptotic. So what'll happen is if we ever get to 16, like, we'd be screwed anyway, but like if computers ever get that fast, like the current way that we would handle a single password on a load of 16 is like it takes 5 or 6 hours to hash it. So you're getting closer and closer to Bitcoin, right? So I mean, these things are insane. But yeah, these load factors, like bcrypt is like asymptotic, and so does the PDK one. That's the same thing. You just change your load factor by 1, and it's like, I forget, it's like 10 times as complex as the previous one or something. So there's a lot of information out there about it, but the good rule of thumb is just pick a really slow algorithm, or make your iteration count like massive. Another thing that everybody should be doing is you should be salting your passwords. Always, always. Salting does, the only thing that salting is going to do is going to prevent people from using lookup tables. So lookup tables are these massive matrices of known passwords to known hashes. So they essentially like, they'll make a lookup table for SHA-256 20,000 times, because that's the Python standard, right? So Python, out of the box, Django, they use, they use PDK 24,000 times, right? So it's easy. You just build a lookup table. You just go through the dictionary, you build a lookup table, and now you know all those hashes. And so if somebody's not salting it, all you do is you just go look up in the lookup table, and now you know their password. If they pick something relatively, non-complex. So that's what salting is preventing hookups. You have to store your salt right next to the password, because otherwise you won't be able to decrypt it or hash it and make sure that they're equal. So that's why they don't add any security, except they're preventing those lookup tables. Does that make sense?
You do the salting before the hashing, or is it the other way?
Yeah. So here's a good example. Like, let's say this is my password. It's like, it's not, by the way. Sorry. So like KSI, some garbage dash, and a bunch of stuff. That's really hard to type, right? And then what you would do is you take a salt. So I just generated like a secure UUID, which is whatever, 128 bits of garbage. And then I add some characters around it. And that's it. And you just do this in memory, and then you hash that. So that hash would turn out to be some big nasty string, and then you would go to the database and you say, hey, my big nasty string equal to your big nasty string. And you know the password there.
And then the salts are random too, right?
Salts are random, yeah. So we just generate a secure UUID, which you essentially just generate 16 bytes that bring EU in. So it's pretty easy. And yeah, the only thing that does is it prevents lookup tables. Okay. So, all right. So that's it on passwords. You guys can geek out on passwords later. I got 5 minutes, so I'll just do this really fast. All right. So this is a cartoon. Classic. I think this is the same thing as XKCD, right? So hey, your son there, yeah. Is your son's name? Robert. Drop table students. Oh yeah, it's a little baby. Bobby tables, right? Looks like he blew away all of his user data. So this is what it looks like in the real world.
Sorry, real quick.
Yeah.
Can you go back to that two slide before?
Yep. Cool. All right, so this is what it looks like in the real world, right? A lot of people will have these sort columns, and like, how do I actually organize tables? And like, if I click the columns, how do they sort up and down? And what they'll do is they'll just slap on this like first name, descendant. And then it just get tacked on, like right on the end. I take that string and I literally bust it right into my SQL. Okay, so I can do this. So what I can do is I can pass in a SQL cast. I'm going to grab your email, and I'm going to grab your password, and I'm just going to grab the first user, which is select from users, limit 1, and then I'm just going to do something garbage that the SQL compiler is going to complain about. I'm going to try and cast a string to the date. So that's going to fail, but that's okay. I want it to fail. Because once it fails, you'll get something out that looks like this. You're like, ooh, admin at Microsoft.com, which is normally what user number 1 is, right? What's user number 1? It's always the admin account. Or it's like some super user account, so it's always like grab one unit and see what happens. So you'll get this. User or admin at Microsoft.com, something cache is not a date. Perfect. I now know the user name, and I know the password. So now if I just have a nice Bitcoin ring, I can bust that password out, and now I can log in as root to that app, right? So it's super easy tricks. So always use prepared statements when possible. Never use string concatenation, and then try and use like code to handle parameters. So you might instead pass something like this.
I'll go back. Sorry.
Yep, no, that's good. Sure. Yeah, I've got like 3 minutes left somewhere. Okay, so you can put a string on there, right? And I'll send you something else. Put a string on there, and then you just have a little bit of code that says like, hey, is this enum equal to first name down? Yes, then I'll add that to my order file. Okay, now I'm safe. I've now protected myself from a lot of problems simply by adding like 3 lines of code. You can add the question mark. A lot of times what will happen is people like take things that come in the URL or different form fields or whatever, and they'll just jam them into SQL statements. That's bad. You don't want to do that. You want to use the question mark, which is a prepared statement instead. And then what will happen is if somebody passes in that nasty string that gives them the first user, like I did before, it all gets nicely escaped because the driver knows how to take the question mark and actually translate what you put in there in the string. If you just concatenate the string yourself, it's going to think it's SQL and it's going to execute it, and you're going to get that nice error that tells you the admin username and password. So use prepared statements. Okay, so I'm sort of out of time, but that's basically it. The rest of it's just kind of like make sure your configuration files aren't world readable and writable. Make sure they're owned by the user that's running your application, and not root or not some other ordinary user. Lock things down, essentially. Just be anal. So like, if you have a config directory, just make sure that it's owned by your application user, not anyone else. And just lock it down. Make sure that the second digits on everything are zeros. The only person that needs to read that configuration, which by the way has the username and password to connect to the database, which means if I get access to this box, I can just spend all day reading your database, right? Because I'll have username and password. Make sure that they're only readable by the application user and not readable by the world. Because that's the first thing anyone's going to do is they're going to like, list open files. It says config. Perfect. Let's go read all of the open files and see if you have access to them. And then once you find the username and password of the database, you connect, and you're in. So lock this stuff down. That's another simple one. Lock down your user on your database. So make sure that your database can only be accessed from your application server. So you can lock everything down by IP address and port that's coming in the IP tables. And then do this is the next step. Make sure that the user that's actually connecting to your database is only allowed to connect from that server. Right? So it's the same thing, it's just another layer of security. So that's what these grants do. Create these grants. Sweet. All right, well, anybody have any quick questions?
2 questions. One, can we need your email address and email you for the slides?
Absolutely.
If you want to post that for everybody.
Yeah.
The second question is, I know a lot of this information is out there on the internet. Is there a company or a community that's standardizing and making this like a benchmark for people to start following?
So Stack Overflow's like InfoSec stuff is pretty good. Obviously, there's no really big post about it. We've been tempted to take the collection of what I've kind of gathered and make that one of the big posts. They do that in some of the other communities. Like, oh, by the way, here's all the things you need to do. I've written a book. There's a couple other websites that have sort of these things step by step. Some of the hosting companies, like Linode, they actually will pay people to write these things. And then what they'll do is they'll just have like a top level page that just links out to all the other pages with all these bits of data. Right? And so Rackspace has DreamHost has some of that stuff. So there's a lot of hosting companies that try and help you navigate this. But yeah, I mean, it's pretty scattered. That's the problem. All right. Yeah, let me give you guys my email really quick. I'll just do an internal really big. Pretty easy.
If you want to highlight real quick, so bring up all the GitHub site where all this is at.
Yeah.
Brian at inversoft.com.
Yeah, we can do it. Go to that. INVERSOFT, Inversoft.com. Just give me up, and you guys back. And then if you go to Inversoft's GitHub account, which is just GitHub, oops, sorry. If you just go to github.com/ I think it's just /Inversoft/, you can list all of our public GitHub repos. We got a ton of them, but so we have a ton of them, but the one that you'll be looking for mostly is this 2016 security scripts. So my plan is just to keep upgrading and updating this each year, along with the book as well. So that's the GitHub repo, and it's got just a ton of scripts, chef recipes, and whatever else. And people have been forking the crap out of it and also submitting issues. So if you run across something that you think needs tweaked, just let me know. Just send a pull request or an issue, get right on it. Yeah. It's just github.com/Inversoft. What's that? That if you go to Inversoft.com, there's a big button that says read the book.
Okay.
So it's open. You guys can just scan through that. And the book also has all the links to the GitHub. It doesn't have the presentation yet, but I'll update it with a slide share when I've done the demonstration and get some sleep. And then, I can also email you guys everything. Sweet. All right. Well, thanks so much for coming.